share with you all this video. Now, the detailing that when you are asked to provide detailing, so this is the diagram that you need to draw. Okay. This will be the diagram that you need to draw, and the diagram shows the side view of the beam. It shows the side view of the beam. We're actually cutting through certain part of the beam. Okay. Then at the same time, they show you different sectional view. Sectional view, section 1.1, section 2.2, and section 3.3. So these are detailing of the beam that when you are asked to draw, you have to produce this kind of drawing. Okay? So the first is showing sideway, and the second one is for some representative sections. Okay. So here, what I would like to point out to you is how to indicate the beam that the rebars that you have designed, the flexural reinforcement, the top for the top one and for the bottom one. So here in this slide, I'm using Y. This is previously the type of steel they are still using symbol Y, but in Euro code they use H now. There's no Y. This is Y in the previous BS code. There's Y and R. Okay. So this is using Y, the symbol Y, but in your case, it might be changed to 2H12, 2H16. Okay. And this is the way we indicate. So we draw an arrow like this, and then on this, you draw an arrow like this to indicate this rebar is actually 2Y or 2H12. And the last one here is the bar number. Okay, in your design project, if you can give the bar number, that will be the best. If you don't have the bar number, it's also okay. But when you have bar number, it's easy to identify in different diagrams. So these are bar numbers. Okay, dash 02, dash 03, dash 04. These are bar numbers. And bar numbers is easy for construction, for contractors. When they want to cut the bars and then where to put the beam, they refer to the numbers. Okay? Then the other thing is that you have to be aware is how to indicate the link. Okay, the link that we expect you to be able to indicate will be what is the size of the link. For example, H. This is Y8. I think H8-10-250. So what we expect you to do is you have to indicate what is the size, at least the size of the link that you are going to use, and then what is the spacing. Here, it also indicates how many links. Okay, it also indicate how many links. This one already calculated with this spacing. If the link has to be provided over this span, how many links is also given here. But in your design project, we expect you at least to show what is the size of the links that you use, H8 dash the spacing. That is the minimum required. But in some actual drawings, they indicate actually how many bars that we are using. Okay. Now, the next thing in sectional view class, in sectional view, we cut through certain representative sections where the rebars details are different. Okay? And this is shown in section 1.1, section 2.2, and section 3.3 here. Then, on this sectional view, you are going to show the rebars using circle here, using the circle, solid circle, then the link. So when you show the link, so this is a link, and also please show the hook here. So the link has to be properly hooked. So the hook, you have to show the hook there. These are the hook here that you have to show in the sectional view for the shear reinforcement. Okay. Then, in order to indicate this rebars here, which is represented by the solid circle, we indicate here next to the rebars there, 2H16. And this, as I mentioned, this number at the back, this is bar number. Bar number, which is easy to identify. Where are they? What kind of size? What is the length required? So you have to write close to the rebars here in the sectional view. The rebars detail 2H16. So we know this is two numbers there. You show by two solid circle, and there are two. The size is the size is 16 mm diameter. Okay. Now, if we have rebars detail in this way, if we have rebars detail, this one I will share with you all. Okay, this is also recorded. The extra notes that I prepare here, I will share with you all. So you please listen first. Now, for the rebar details, okay, if you have two layers, then you have to indicate for each of the layers the bar details. So 2H16, 2H16. And here you have 2H12. Okay. If you have a rebar detail in this way, if you have a rebar details like you combine different sizes and they are all in the same layer, so try to indicate using different size of the circle, different diameter. Try to indicate, okay? So this one is larger size, and at the center there's a smaller size one. So here we write as 2H25. So we know there are two here plus one at the center, which is slightly smaller. It is shown using smaller circle. So we have 1H16. And you have the top there, 2H12. So class, this is the expectations for rebar details. Okay, how do you draw and what kind of information you should provide on the drawing? Okay. At the back, can you hear me? Yeah, because I have to fight with the aircon. The aircon sound. I have to fight with the aircon sound. At the back, can you hear me? Now, in the bar that you draw in the drawings, number 1, number 2, number 3. So the workers involved have to look at the company or the person who is going to put the rebars. They have to look at your drawing, and they look at the bar. There's a schedule that is called bar bending schedule, where number 1, number 2, number 3, number 4 is indicated there. So they will cut into the size. So number 1 is maybe just straight bar. Number 2 is there's a bend. Number 3, there are different length. So these are the things that they have to rely on the detail that we provide in the drawings. Okay, it cut in the required lengths and end details. Some of the bars are bent, some of the bars are bent more, but some of the bars are straight without bend. So this has to be provided through the drawings and later through a bar bending schedule. They have a bar bending schedule which show them bar number 1, bar number 2, bar number 3, what are the sizes, what are the length, what are the end details. Then only they can follow the drawings, I think, put in the rebars. Okay? Put in the rebars. So once they put in the rebars and then the engineers check that these rebars are following whatever design that we want, then only this rebar is lower into the formwork. So this rebar is still not lower into the formwork because we provide the detail first and then we do the checking. Okay, then we lower into the formwork. Yeah, lower into the formwork here, because it's very difficult to work inside the formwork, so that's why we put it, tie it at the side there, above the formwork first, supported by these pieces of wood. Okay. So here we can see the shear link. You can see also the main bars, the top bars, and the bottom bars. Okay. So when we want to produce detailing drawings, I think there are a few things that we need to remember, we need to understand. The first thing is curtailment. Yeah, what is curtailment? Is the bars, the rebars that we design. Okay, we design as the section where the bending moment is maximum. So when it's away from that sections, we don't need all the rebars. If we need 4 at the maximum sections, as we move away from that sections, maybe two is sufficient. So this is curtailment. Until where we should provide all the rebars, until where we can cut them. These are curtailment. Okay? And there are rules and guidelines that we are going to discuss that you have to follow. And the other things that we have to, in detailing, which is important, is anchorage length. The bar must be anchored with the proper length. If not, then the bar cannot function properly to take the stress. And there are lap length. Lap length is when we have rebars. Rebars come in certain size. Okay? When your beams, continuous beam is very long, and then the rebars have certain size, maybe 9 meters, 6 meters. So we have to lap them. We have to provide lapping. So there are requirements for the lap length so that the stresses can be transferred nicely from one bar to the other bar. Okay, so these are the few things that we need to be aware of when we are talking about detailing. Okay. Now I'm going to go one by one. The first on curtailment. Okay. Now, curtailment, we do not have a specific rules, very detailed to calculate them. Later, there are some guidelines that we can follow based on experience. Okay. Now, the idea of curtailment here is shown in this diagram. So in this diagram, what I want you to understand is that here, the bottom rebars, we have three groups, 1, 2, and 3. The top rebars, we have also 3 groups, which is labeled as 4, 5, and 6. Okay, and the top rebars, they are placed in 2 layers. They are placed in 2 layers, but the bottom rebars placed only in 1 layer. So 1, 2, 3 here means, if we look at the bottom rebars, they divide this into three groups. So group number 1, the rebar number 1, is the rebars which is going to extend, until the end. Okay, this is going to extend until here. This is 2 and 3. Okay, 2 and 3 is going to extend until here. 2 and 3 is going to extend until here, and 2 is going to extend until here, then stop, and 3 is going to extend further across the support. So these are what we call curtailment. Okay, and bar number 1, group bar number 1 is only going to place somewhere from the midspan up until some distance from the support, which is indicated by this small line here. This small line is trying to show to us that there is 1 bar here which is stopped here. From here until there is bar group number 1. It doesn't go until the end because it's not needed. You do not need to provide until the end. Only 2 and 3 go to the end of the support here, and 2 go stop somewhere before the support here, but 3 go beyond the support. Okay, so 1, 2, and 3 has different numbers. Group number 1 maybe 4 numbers or 6 numbers of bar. We cannot see from here. Group number 2 maybe 4 numbers of bar only out of 6, and group number 3 maybe 2 only. So this is curtailment because the maximum moment is somewhere at the midspan here. This is where the 6 number of bars is required. For example, as you go to the support here, the bending moment getting smaller and 0 by right at the support there, so we don't need all the 6 bar there. We just need to provide some minimum bar according to some rules. Okay? The same thing for the support. For the support, we design for the hogging moment maximum here at the support here. So this one, let's say 2 layers of bars are needed. 2 layers of bars are needed, maybe So first layer is 4 bars, the second layer is 2 bar. The maximum moment is there, so you need the highest number of rebars. So as you go away from the support, the bending moment, the hogging is getting smaller until it changes to positive. So as you go to smaller and smaller value, so this number 6 bar, which is needed at the support where the moment is maximum, so it stopped here. It stopped here, then only group rebars, group number 5 need to extend until here, then stop there, and then the rest maybe some rebars, group number 4 go beyond, go a little bit further. Okay. So this is the idea of curtailment. Okay. Because of course you can also provide beams, provide the rebars that we design here. Let's say 6 bar, we provide until the end 6 bar. We provide until here 6 bar also. We can provide that, but if you have only a few beams to design, to cast, then maybe it's not a problem. But if you have many beams to cast, then if you don't curtail, then your rebars that we require will be more. Then this will increase the cost. So curtailment will be helpful for us to stop where the rebars is not needed anymore. Okay. So this is the idea. Okay. Just look at this diagram as an idea of the curtailment as explained here in this explanation. As the magnitude of the bending moment of a beam decreases along its length, so may the area of reinforcement be reduced. So area of reinforcement reduced means number of rebars that we need to provide can be reduced by curtailing. So this is the meaning of curtailing. Yeah, you cut it somewhere, stop it somewhere, no need to go further. This is curtailing the bar since they are no longer required. Okay. So this is the idea here. Again, I show. Okay. The rebars that you've designed class is based on this maximum moment here. So as they go along the bar, the bending moment decrease. So the rebars that you design here full is not necessary to go. You provide full until the end. So you can slowly reduce them, curtailing them. The same thing for the positive moments, the bottom rebars. Okay. Now, what I want to say here is that, as I mentioned earlier, this statement here, the curtailment, we don't have to do a detailed calculation to see until where we should, how many bars we should go, but we are going to use some rules. Yeah? We are going to follow some rules which come from experience over the years. Now, this is the idea of anchorage length. Okay. When we curtail the bar, when we decide to curtail it, no longer needed, but the bar has to extend a bit further along the beam because the bar has to be anchored. So this is called anchorage length. Each of the curtail bars should extend when you decide until here, this is a rebars needed, but you cannot stop. You cannot stop immediately there. You have to extend. Make sure the rebar extend a full anchorage length beyond the point where it is no longer required. So anchorage length is rebars. We know rebars, it is cast into concrete. So when you cast into concrete, the rebar must have enough length of concrete to hold the rebar so that when the rebars is taking the tensile stress from the bending, it can resist the tensile stress without being pulled out. So you need to hold it. This is the idea of anchorage length. So the diagram here shows the idea of anchorage length. So the rebars is resisting tension. Okay. Then it must be anchored properly. It must be anchored enough length. And the anchorage depends on something. It depends on the bond between the bar So the bond must be good bonding. This is what holding the rebars to the concrete. The area of contact. So this one will be decided by the length as well as the diameter. It's the area of concrete, area of contact, whether or not the bar is located in region where good bond condition can be expected. Now, when we cast the beam, so the bar at the bottom of the beam tends to have better bonding than the bar at the top of the beam, because when we cast concrete tends to flow better naturally to the bottom. So this is meaning the location of the bar. The bar at the bottom, close to the bottom of the formwork, when we pour concrete, tends to have better bonding than the bar at the top, because gravity, when you pour concrete flow better to the bar close to the bottom there. So there are factors. There are some factors, conditions that we can make use of to consider all this. Okay? Now, in your design project, we do not expect you to go into very detailed calculate the anchorage length, but here there are formula here. Yeah, formula here. This is the equation for design anchorage length. So design anchorage length depends on the characteristic strength of the rebars, Fyk, and it depends on the bonding, design bonding stress. And also it depends on the diameter and depends on what we call coefficients. You see alpha n here is called coefficients. And this coefficients is given in the code. Coefficient alpha refers to many different conditions, and the code gives us the range of the value of alpha that we can consider. So you multiply with alpha 1, alpha 2, alpha 3, alpha 4. There are many alpha there, alpha 6, I think. Then you multiply with diameter of the bar. You multiply with Fyk. You divide it by 4.6 FBD. FBD is the design bond strength. Okay? Then we get the design anchorage length. So this is the anchorage length that we need to make sure the rebar must be properly held in place. Okay? And it is indicated using the symbol LBD. Okay? Now, as an guideline for you, for straight bar with diameter less than equal to 32 mm, so the anchorage length is about 52 diameter for a top bar, okay, and about 36 diameter for a bottom bar. This is for C30 class concrete, and the bar diameter less than 32. I think in your design project, nobody is going to use for your bungalow 32 mm rebar. Any one of you use 32 mm rebars? Okay, most maybe 20 you use. Yeah, 32 less, so applicable to your design. The diameter less than 32, so it gives you an indication. Anchorage length is 52 diameter for top bar, and about 36 diameter for bottom bar. So the top bar requires longer anchorage length than the bottom bar, because the bottom bar, the bond is better. Okay? So this is some figure that you can use for your anchorage length. Okay? Now this alpha n here, the coefficients are given in the code, and these are the alpha that the alpha 1, alpha 2, alpha 3, alpha 4, until alphas. There's many alpha here that we need to consider. Okay? And there are many factors here which is taken into account. So this is a bit small if you refer to your notes. What are the factors? Shape of the bar, concrete cover also influence. And then there are some alpha values given. Okay? So these are the alpha that need to be considered to multiply to get the design anchorage length. Okay? Now in bond stress, yeah? Bond stress, there are for different FCK, and for bar size less than 32 mm, this gives us the design bond stress, design value of bond stress, which is needed to calculate anchorage length. So the higher the FCK, the better the bond strength. Okay. This is for bar size less than 32 mm diameter and good bond conditions, for example, bottom bar. And this is for bar less than 32 mm diameter and poor bond conditions. For example, top bar, top rebars is considered as poor bond conditions. So the design bond will be less for top bar, and for bottom bar, the design bond stress is higher. But this is only for bar size less than equal to 32 mm. Okay. Now, okay, this is actually there are some equation that we can use to calculate the curtailment, but you do not need to go into detailed part of this thing, but I just share here there are some calculation that we can do to decide the curtailment. Okay. So this again, I have already shown to you this diagram here. So for your design purposes class, I think what I would like to stress here is the anchorage length that you should consider. You can take this as a guideline. 52 diameter for the top rebars and then 36 diameter for the bottom bar. So this is for C30 class concrete. Okay. Okay. So now there are curtailment, there are some rules that we follow. Curtailment, okay? So this comes from experience over the years, and the first thing is class, at least 1/4 of the bottom reinforcement should extend to the support. So when you have support, at least 1/4, which is if you have 4 rebars, 1/4 is, if you have 4 rebars, 1/4 means 1 rebars. Okay, at least 1. But we don't extend only 1, but we extend 2, for example, at least 25%. 1/4 of bottom reinforcement should extend to the support. Okay, the bottom reinforcement at an end support should be anchored into the support as shown in the figure. Okay, so it should anchor the length equal to the design anchorage length, anchor into here. And if it is a cast, if there's a column here, then if it is supported in this way, then anchor through the beam. If it is supported in this way, then anchor into the column. So the anchor length must be LBD, which is the design anchorage length. Okay. Now, there are two kinds of end support where there is little or no fixity of the bottom steel. And there is little or no fixity. The bottom steel should be designed to resist a tensile force of 0.5 FED to allow for tension induced by the shear with minimum requirement of 25% of the reinforcement provided in the span. So for the case of end support, then the bottom steel at the end support, we should design to resist tensile force. This is coming from the shear. This is coming from the shear at the support. So we have to make sure that the rebars is able to take this amount of forces. Then the minimum requirement is the same as here, 25% of the reinforcement provided at the mid-span there. Then at the end support where there is fixity. Fixity means the beam is cast into the frame. Okay. But in your continuous beam, you analyze as a simple support, then you should provide a top steel. Top steel should be designed and anchored to resist at least 25% of the maximum span moment. Although we design as simple supports, but if it's actually the beam is cast into the column, So there will be some form of negative moment. So you should provide top steel there. And this top steel is 25% of the maximum span moment. So these are some of the rules that we follow. Okay. Now, at internal support, yeah, you have continuous beam, there is an internal support. Then this bar here should extend. Yeah, the bottom bar here should extend from the face of the support here at least 10 times the diameter of the bar, the bottom bar. Okay. At internal support, the bottom steel should extend at least 10 bar diameters beyond the face of the support. So we cannot stop here. You have to extend here. Yeah, you have to extend here. At least 10 diameter of the bottom rebars here. And if you have one coming here, and this is not continuous, so you have to provide a kind of lapping. So the lapping here should be from the center line of this at least equal to the design anchorage lap, a full anchorage lap on each side. Okay. So this is at the internal support. So in your detailing drawings, so the rebars at the internal support, it shouldn't stop here. Okay, it should extend beyond here. It should still extend beyond here. Then there should be a lapping here. There should be a lapping here. Okay, so that we ensure there's a continuity of the rebar. Now, lap length is required when our beam is long and the rebars is coming in certain size. So rebars doesn't come in indefinite long length. It comes in 6 meter or 9 meter, but it's too long, also difficult to handle. So it comes in certain size. So when we need a longer rebars, as in the beam, we have to put lapping. Okay. So lapping also, there are some considerations, some equation to calculate the lap length. Okay. Here I show you one idea of lap length is there's one rebars coming here, one rebars coming there, which is in the beam, and these rebars is not long enough to go further, so we have to do the lapping. Okay. So lapping is often necessary to transfer. Yeah, we must make sure this when transfer this can transfer nicely. So this is through proper lapping. Okay. And lapping should not be when you need to do lapping. You don't do lapping at the same place in the beam. You do lapping at different places. This is meaning staggered and should not occur in region of high stresses. Lapping you should not place in the mid-span where the stresses is high. So you should avoid those locations, and you should not put lapping concentrate in the same locations. Okay. The length of lap should be based on minimum anchorage length. So again, we need to go back to anchorage length, and then there are some factor to be considered, and we can modify the length. Okay. Now, these are some of the rules that I think when we do detailing, we might need to refer to. Okay. But what I'm going to show you with the next slide is for certain cases, there are simplified rules. And this simplified rules is given in your design formula book. Okay. And these are the cases where the loads on the beam are substantially uniformly distributed. Simplified rules. Next slide, I'm going to show you, and that slide also appear in your design formula book. Now, there are some restrictions. Yeah? These rules only apply to continuous beam if the characteristic variable load, your QK, does not exceed characteristic permanent load. So these are the conditions, and the spans are approximately equal. So there are figures here, which is give us the rules. So here it gives you the case of simply supported, the top one, and the case of continuous beam. So these are simplified rules of curtailment. Okay. So what this figure shows us is for simply supported with span L. So what you design is at the mid span, let's say four rebars here. So the 4 rebars should extend at least until 0.08 L from the middle of the support line. Okay. At least it should extend until 0.08 L from the middle line of the support. Then the rest 50% should go until anchored properly into the support. So if you have 4 rebars here, let's say 4H16. So 4H16 will stop somewhere here, 0.08 L before from the center line of the support. And 2H16 should extend further into the support and anchored properly. So this is for simply supported. And if it's for continuous beam, then you have these rules here. Okay. So these rules apply to other end span and middle span. So you have 100% is at the support here because this is what we designed for the top rebars. Okay. Then the 100% should extend from here until at least 0.015 L from the face of the support. Okay. Then the rest, the 60% should extend until 0.025 L from the face of the support. Then the remaining 20% should go until the end. Okay. This is for the top bar. Okay. For the bottom bar, then we design for maximum moment somewhere at the mid-span here. So 100% should extend until about 0.1 L from the center line of the support here. And for interior support, it should be 0.15 L from the center line of the support. Then 30% should pass through. Yeah, 30% should extend through here. And the other 30% should anchor properly into the support. Okay. These are simplified rules, class. Simplified rules, and there are conditions. Okay. And this one you can find in your design formula book. Yeah. Please check. Okay. In your design formula book, sorry. Design formula book, I think section 11. Yeah. Okay. Section 11 gives you simplified curtailment rules for beam. Or page 17. So the so here it is because those which is shown in EC2 and this is from BS. This is the percentage here that you can see they are slightly different, and the dimensions here also slightly different. So when you want to do your curtailment, you can follow. You can follow this. You can see there are some slight difference between whatever is written here and the one I show you, because the one is taken from practice under Eurocode, but this is from the BS. Yeah? So you can make use of this in your design. to follow this, okay, you can also follow the one that I shown just now, but give the source of the curtailment rule that you follow. Okay, so this is for simply supported beam. This is for continuous beam. This is in your design formula book, and there are some difference between this value here. There's some percentage also different, and this value here will be a bit different. There are some calculation needed to be. Okay. Okay. So class, that is the thing about detailing that you are expected to be able to do in for your design project. So you have to show the diagram showing the, I think, the elevational view of the beam that you design. Then you have to show the sectional view. Okay. Now, if you can follow this, okay, or follow the one in the design formula book, then you can do some curtailing. Or if you do not do curtailing, then you can provide your reinforcement all the way, the whole span. Whatever you design here, you extend until the end. Whatever you design at the mid span, you extend until the end, or you extend to the support. Okay, so that is you don't do any curtailment. Okay, but if you do curtailment, then this will be the simplified rules that you can follow. But there are there's conditions that you have to make sure that before this simplified rules is used, the QK must not be more than GK, and the span, if it is continuous beam, must be approximately equal span. And the load is continuous load. It's not like you have many point load. If the load is continuous, more or less continuous, QK less than GK, and the span is approximately equal, we follow this rule. Okay. So alternatively, you can provide the whole thing, okay, across whatever design here you bring until the end there. Now, if you are asked to, if the question asks you to use, follow the curtailment, do some curtailment of the rebar, then you should do curtailment. If there's no requirements, then you can provide the bar over the whole length. Okay? But in practice, if the number of houses that we have to design, have to construct, there are many, 100, 200, then if you do curtailing, it will save a lot of steel bar required. Okay, but we have to do curtailment properly, follow the rules, do the anchorage, make sure the anchorage is proper. So these rules given already satisfy the anchorage rules. Yeah, you have to have proper anchor. This bar have to have proper anchor. So all the rules have already applied here and then put in the form of rules, which is what we call simplified rules. Okay. Now I will stop here for a while and